your test is going to cover 6.3, 6.5, and 6.6. And then 12.1, 12.2, and 12.3.
6, 7, okay.
Oh, it should be 6.6. Thank you. 6.6. Okay, which was all the function stuff. And started with piecewise functions, got into composite functions, combining functions, all that stuff. And then inverse of functions is how we end chapter 6. And then 12.1, the only really thing from 12.1 that you need is finding the center and the radius of a circle, if you're given the endpoints of the diameter. And then 12.2, finding the equation of a circle, graphing it based on that. And then 12.3 was the ellipsis stuff that we just reviewed. So finding the equation, given information, and graphing it, given the equation. So the piecewise functions are the ones that look like this. So the f of x is true for different values in different ways. So for this one, f of x equals 2 if x is less than or equal to, oh, that should be greater than. X is less than or equal to 1. Or 3x plus 1 if it's greater than 1. So you can have an overlap there because it would fail the vertical line test. It can't be the same dot. So the first thing we're going to do is graph this. So if I said that y equals 2 for those first values, what kind of graph is a y equals 2? It's a line, and specifically a horizontal line, right? The values of y never change. So we're saying this is true for the values that start at positive 1 and are less than or equal to it. So remember, a solid dot is the or equals. An open dot is a not or equals. So if that said less than or greater than, it gets an open dot. If it says equal to, less than or equal to, or greater than or equal to, it gets a solid dot. And then the second part of that graph is that y equals 3x plus 1 for the values that are greater than or greater than 1. So I have two choices here. Plot points starting at 1 and getting bigger than 1. So 1, 2, 3. Plug them in. So 3x times 1, or 3 times 1 plus 1 would be 4. 3 times 2 plus 1 would be 7. 3 times 3 plus 1 would be 10. And then I can plot those 3 points. So 1, 4 would be an open dot because it can't include it. 2, 7, 3, 10. And it's a line, so it's going to keep going on that direction. The other thing you can do is just graph your line and erase the part of the graph that you don't want to use. So if it's y equals mx plus b, I could have started at 1, gone up 1, 2, 3 over 1, 1, 2, 3 over 1, drawn that line, and then erased from it what you don't want to use, which would have left us with exactly what we had drawn the first time. Again, this is an open dot because it doesn't include it, and it would continue on in that direction. Questions on that one? So you are going to have to graph piecewise functions, okay? They're not bad, but you do have to graph them. Ian?
Can you go over, like, if you have, like, an opening that flows down the same point?
So if it overlapped, let's say that this was, instead of this being 2, this was 4. This would have been a solid dot, and I would have gone straight through. The solid dot being on the same spot as the open dot overtakes the open dot and makes it a solid dot.
Yeah, so if there's an opening that closed, it's closed.
Exactly. Okay, and then you have to evaluate the piecewise function. So if it said f of negative 3, using this same function, I figure out which range that falls in. So is negative 3 less than or equal to 1 or greater than 1? It's less than or equal to 1, which means f of negative 3 is what?
2.
Good. How about f of 1? Is 1 less than or equal to 1, or is it greater than 1? It's less than or equal to, right? Which means this one is also 2. And then f of 3, good. It's bigger than 1, so this is the 3 times 3 plus 1, or 9 plus 1, which is 10. Questions on any of that?
The fixed line.
Yep.
Like your point, why is it at 1, 2 instead of 0, 2?
Oh, because it's from where x is less than or equal to 1. So you have to go all the way over to where x is 1.
When it's a quadratic, how do you graph it?
Plot points. So if it was quadratic starting at x is greater than 1, I'd plug in 1, I'd plug in 2, I'd plug in 3, plot my points, and make it the parabola.
How do you know when to do the parabola?
How do you know when to do it?
Yeah.
The points should give you that curve.
Oh,
Yeah. You'll know it from the equation if it's squared, right?
Mm-hmm.
Okay, 6.5 was all the things you can do with functions. So we learned how to add functions, subtract functions, multiply them, do the composite. We also learned dividing, which is not on your test, so let's narrow it down to just these. Okay, so adding, subtracting, multiplying, and then composite functions on the bottom. So if it said find f plus g of x, and it gives you f of x and g of x, all you gotta do is add them and combine your like terms. So this would be 3x squared plus 2x minus 1 plus 4x plus 2, and then combine your like terms. So I'd get 3x squared, positive 2x and positive 4x, positive 6x, negative 1 and positive 2, positive 1. The next one says f minus g. Pay attention to the order. So it says the f goes first, which means I change the signs on everything in g. So the f stays exactly how it is. And then it's minus both terms in g, which is a mistake a lot of you made on the quiz. That minus has to go to both. So this is a negative 4x and a negative 2. This is 3x squared minus 2x minus 3. Then comes the multiplication. 3x squared plus 2x minus 1 times 4x plus 2. And then you would FOIL this out. So I distribute, 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 distribute. So the first one would be 3x squared times 4x, or 12x to the third. 3x squared times 2, 6x squared. Go to the 2x. 2x times 4x is 8x squared. 2x times 2 is 4x. And then the last one, negative 1 times 4x, negative 4x, negative 1 times positive 2, negative 2. Combine your like terms. So this is the only x cubed. There's 2x squared. Add those. There's 2 x's. They'd actually cancel each other out. Minus 2. And then the next one is f of g of 2. So these are your composite functions. And you want to work innermost parentheses out. So the first thing I'm going to do is find g of 2. So I go back to where g is. And plug in 2. So g is 4x plus 2. 4 times 2 plus 2. 8 plus 2, which is 10. And then I want to find f of 10. Go back to the f, which is 3x squared. So 3 times 10 squared plus 2 times 10 minus 1. 3 times 100 plus 20 minus 1, 300 plus 20 minus 1. 320 minus 1, which is 319. And that second overall answer is your answer, not in two parts, just that last one. So we're going to do the same thing for g of f of negative 1. Start innermost parentheses. This time the f comes first. So 3 times negative 1 squared plus 2 times negative 1 minus 1 is 3 times 1 minus 2 minus 1. 3 minus 2 minus 1, 1 minus 1, which is 0. And then I want to find g of 0. So 4 times 0 plus 2, 0 plus 2, which is 2. And then again, that last answer is your overall answer. All right, so that's the start of the review.